Good morning, students. I'm Dr. Neha Sharma. I hope you go through the previous two videos of this topic, that is motion. In previous classes, we have started introduction part of the motion, the types of motion. And in last class, we discuss about different physical quantities. We define it as a scalar quantity and vector quantity by giving some examples. In the last class, we discussed in detail about the distance and displacement. These are the two important physical quantities. So in today's class, we are going to discuss two more physical quantities, that is speed and velocity. So before starting it, the topic is measuring the rate of motion. In this universe, every object or every person is have their own rate of motion. Like this boy is moving with their own rate of motion, whereas earthworm is moving with their own rate of motion. The boy is moving fast, whereas this earthworm is moving very slow. Similarly, if you are driving with a car, you take time a very less to take to reach some particular position, whereas if you are using a bicycle, you are taking so much time by reaching the some particular position. Suppose I am giving you an example that suppose you are going to the school by using a bicycle, maybe you take some specific time, maybe some time t1. Instead of cycle, suppose your father or mother is basically drop you by using their own car, the time taken by the car is less. So every quantity or every object has their own rate of motion in this whole universe, that every object or every person have their own particular rate of motion. So in physics, the term rate of motion is defined as speed. Maybe you heard this term so many times that that particular vehicle is moving with very high speed or maybe some low speed. You maybe now listen this term so in so many times. So what is a speed? As I'm in the previous slide, I'm giving you an example that you are going to your home. You are going to your school from your home. So the distance from your home to school is fixed. The vehicle you are using by which the time is taken is less and more, right? So basically the two important parameters on which speed depends is distance and time. So what is speed? Speed in physics is defined as the basically the total distance traveled by any body with respect to time in any direction, right? And it is represented by small v. Mathematically, you can define it as the distance traveled by object by time taken by an object to travel that particular distance. That is, distance in last class I have defined the distance is denoted as small s. So if v is equals to small v is equals to small s by t, right? So as I'm saying that in a previous example that you are going to your school from your home by bicycle or by car, so the distance is same, but the time taken by the object by car or by bicycle is different, by which the speed is also differ. I hope it is clear to you. The unit of this speed is the meter per second. It is the SI unit of speed. What does it mean? SI is related to or denoted as International Standards of Unit. So its standard unit is meter per second, but it has so other units like kilometer per hour, meter per hour, etc. And it is used very widely. Like in your car, there is some speedometer. In a right corner picture, a speedometer is shown. The unit you observe is km per hour, that is kilometer per hour. It denotes a speed. In some speedometers, you might observe the unit is amperes, that is miles per hour. It denotes that if the speed is approximately 100 kilometer per hour, means if you are driving a car with a speed of 100 kilometer per hour, that means in a particular hour you covered by using a car 100 kilometer distance, right? Or if I'm saying that the distance or the speed of the car is 40 kilometer per hour, sometimes you observe that speed limit is mentioned, that is like just like a right corner picture, that is 50 kilometer per hour or 40 kilometer per hour. So that is the limit. So the distance is means the your speed would be the 40 kilometer distance should be covered in a 1 hour. So the speed is minimum in that case. Sometimes a center picture represent a very interesting picture that during cricket match, the bowling speed is also mentioned in km per hour. It's how the bowler is thrown some ball with some particular speed, and the speed is mentioned in the unit is kilometer per hour. So the unit of the speed is in SI unit is meter per second, and other units are meter per hour, kilometer per hour, and so on, right? So speed is the basically related to the two important terms, that is the distance traveled divided by time. So in the last class we define the uniform motion and non-uniform motion. We define uniform motion as any type of motion in which a per equal distance is covered by a equal interval of time, right? And non-uniform motion we defined as that equal distance is covered or unequal distance is covered by equal interval of time. So uniform motion is type of some ideal type of case, and non-uniform motion is type of some realistic and practicalistic type of case, right? So if we consider a speed, if you want to apply a speed in a real example, so I consider, suppose when I consider a speed in non-uniform motion. So in that case, non-uniform motion is a different speed is covered by the some particular object in a particular time. Suppose I am saying that I am going from Delhi to Jaipur, the speed might not be uniform because maybe I'm facing some traffic or I'm varying my speed. Sometimes I'm taking driving a vehicle from 100 kilometer per hour, and sometimes I'm driving a very slow like 60 kilometer per hour or 40 kilometer per hour. The speed is vary. So in that case, we just identify the total distance travel. So we don't calculate the speed by applying some direct formula, the distance by travel. In your non-uniform motion type of cases, we normally calculate the speed as average speed. That is related to the total distance traveled divided by total time taken. You can understand this thing by this example. This example is of your book. I'm taking from your book that some object travel 16 minutes in 4 seconds and another 16 minutes in 2 seconds. Means the person is not traveling or object is traveling 16 meter distance, and first time it takes only 4 seconds and second time it takes only 2 seconds. So this is a non-uniform type of motion. So what is the average speed? So normally we have taking we're calculating a average speed in a case of non-uniform type of motion. So how we will do this? We that is average speed is total distance traveled by total time taken. So how we calculate the total distance? We just add these two distances, that is 16 meter plus 16 meter is 32 meter. In second part, the total time taken. In a first case, the time is 4 seconds. In a second case, the time is 2 seconds. So total time is 6 seconds. So average speed is 32 meter by 6 seconds. So it is calculated as 5.33 meter per second. I hope it is clear to you that in case of non-uniform motion, we calculate a average speed. That is sum of all distance means total distance traveled divided by total time taken by any object. There is one more example of calculating a speed. Suppose if you know the value of a speed or if you know the time, you can actually identify the distance covered. Suppose I am giving you an example. Suppose one object is moving with a speed of 50 meter per second and the time taken is 1 minute. That is equivalent to 60 seconds. So calculate the distance traveled. So distance can be easily calculated vice versa. Speed is distance by time. So distance is speed multiplied by time. Speed is 50 meter per second and time is 1 minute. So we have to convert that 1 minute into a second because unit should be same. So 50 meter per second multiplied by 60 second, that is 3000 meter. One more example I am giving to you to calculate a speed is, suppose total distance covered by a car is 100 kilometer into 1. So you can easily calculate the speed is distance by time 100 by 2, that is 50 kilometer per hour. In all these example, if you notice that this physical property or this physical quantity is just give you some values, that is it is provided you some magnitude, it is not showing you that in which direction it is moving. Suppose I'm giving you example that some car is moving with a speed of 100 km per h, so it is not giving you that direction, that in which direction it is, in north, south, east or west. In a previous example I'm giving that speed is given, time is given, you have to identify the distance, but distance in which direction, the direction is not mentioned in all the cases. In all three cases, only the values, the magnitude is provided to you. Magnitude is identified by you, but the direction is not given and direction is also not discussed. So speed is a scalar quantity. As in a previous class I defined that scalar quantities are those type of quantities which has some magnitude or which depend on the magnitude, but does not depend on the direction of the object. So speed is a scalar quantity because it provides you some magnitude only and does not depend on the direction. So in physics, there are some more quantity which are actually related to the direction also. Means we know that every object is in motion, right? And every object has their own rate of motion. That is a speed. So if we multiply that speed with a direction, that some person is moving in at particular speed in particular direction, then this quantity in a physics is defined as a velocity. So velocity is speed multiplied by direction. So means speed with direction is velocity. Velocity, because it is related to the direction part also, so it is a vector quantity. As in this example, suppose I'm saying that some car is moving with 40 kilometer per hour. If the statement is up to 40 kilometer per hour, so we can say that it is a speed. But if I'm saying that car is moving in east direction with 40 kilometer per hour, so in that case, we am talking about a velocity, because velocity includes a direction part also. So velocity is a vector quantity because it includes a direction. And the unit of velocity is the same as a speed, that is meter per second or kilometer per hour. So I hope the difference between these two quantities is clear to you, that speed is a scalar quantity. It does not include any direction. Velocity is a vector quantity. It's a vector quantity. It includes the direction. So as I'm taking a case of non-uniform motion in a speed, similarly for realistic example, I'm also taking a case of non-uniform motion while discussing the velocity part. So the velocity is the distance traveled by the object in a particular direction by time taken by object. The term in a particular direction, this one term is included, and this denotes a velocity because we are include a velocity part. So in a case of non-uniform motion, this ratio is defined as the average velocity, because distance traveled by or total distance traveled by an object is different and time is also different. That's why we are taking a sum. As like average speed, we calculated the average velocity in that case. If you remember, we discussed that in a previous class that distance traveled by an object in a particular direction is defined as displacement. Displacement is again a vector quantity which includes a direction also, and it is the difference between the final position to the initial position. So average velocity can also be defined as displacement by time taken by any object. So if you remember that displacement depends upon initial and final position. So average velocity is also like behave like a displacement. It is also depends on the initial and final position. So average velocity is calculated by means of arithmetic mean of initial and final velocity. What does it mean? Arithmetic mean is actually related to the value of some objects divided by total number of objects. Suppose in this example, one particular object is moving from point A to point B. Point A is the initial position and point B is the final position. So in that case, when some object is moving from point A to point B, the arithmetic mean is A plus B divided by the number of objects by 2. So in case of velocity, the initial position or initial velocity is denoted by small u and final velocity is denoted by small v. So the average velocity is the arithmetic mean by number of objects, that is u plus v by 2. Suppose some person or some student is by taking a bicycle is moving from point A to point B. Point A initially is at rest mode, so we consider u equals to 0, and point B is having some velocity up to point B is v. So average velocity is u plus v by 2. There is one more example, like there are town A and town B having a distance of 20 kilometer. If we are moving from point A to point B, it takes approximately 2 hours to reach that point. Suppose due to some construction work, a person is moving, taking some another path that is having a distance of 50 kilometer, and it takes approximately again a 2 hours to reach that point B. So the average speed is the total distance by total time. The distance is 50 kilometers covered divided by time is 2 hours. So the average speed is 25 kilometers per hour. And average velocity in that case is the displacement is the difference between the final and the initial point. So the displacement is 20 kilometers and time is 2. So in that case, average velocity is 10 kilometers per hour. So to understand the difference between average speed and average velocity, I am taking one more example. And I left picture. A student or person is moving from home to school, point A to point B. The distance is 5 kilometers, right? And the distance traveled in 1 hour is 5 kilometers. Means it takes approximately 1 hour to cover that distance. So we have to find out the average speed and average velocity. So in the first case, the average speed is the distance by time, that is 5 km per 1, that is 5 km per hour. Average velocity, because the distance is final position and initial position is same, that is 5 km. So displacement is 5 km per 1 hour, that is 5 km per hour. So in that case, the average speed and average velocity both are same. If I am taking a second case, a second picture which is on right side of that PPT, suppose that boy, after their school hour, is again moving back to his home. So in that case, we have to identify the average speed and average velocity. In that case, now the average speed, the total distance covered is 5 plus 5, that is 10 kilometer, and total time is 1 plus 1, that is 2 hours. So average speed is 5 kilometer per hour. But the displacement is, because initial and final point is same, so that is 0 and the time is 2 hours. So displacement or average velocity in that case is 0. So I hope it is clear to you that how average speed and average velocity is calculated by giving data. Average speed is depends on speed or direction. We know that speed is constant, but velocity is not constant. As if some car is moving in a circular motion, in that case, speed is constant, right? But velocity is not constant, because when it is moving in a circular motion, the direction is changes, so displacement is varies. So if displacement is varies, so in that case velocity is also varies. So velocity is not constant, but speed might be constant because the distance covered by the car is same. This is one more example which denotes or that how we calculate average speed and average velocity. That some girl Usha swims in some particular direction, that she cover 180 meter in 1 minute by swimming from one end to the another and back along the same straight path. So we have to find out the average speed and average velocity by taking some previous example, that how we calculate average speed, that is total distance by total time. We have to look after the units, that unit should be same, and we calculate the average speed by and average velocity, because initial and final position is same, so displacement is zero in that case. So average velocity is zero and average speed is 3 meter per second. So I hope this topic is clear to you. This is some assignment question. This is actually the exercise question of your book. Try to solve this question. In next class, I will discuss the solution of this question. Then further topics we will discuss. Thank you.